Hey guys, Joshua Clemons. I'm not actually in class right now. I don't know if I fooled all of you. I'm out with the commercial flight ops group right now. We're at American, touring the facility. We should be back, I hope, tonight. But in lieu of me not being in class for my presentation, I decided to record it for you guys so that way you can still see my loving face, even when I'm not there. But either way, cut the intro short, we'll get started. Clearly, I am going over the auto-throttle system and how it interacts with the aircraft. I'm sure all you guys know at this point what the auto-throttle system is. The auto-throttle is a system that allows the pilot to control the power setting of an aircraft and of the aircraft's engines by specifying a desired result and then automatically configuring the engine or the speed, depending on which mode you select, to reach that result. It controls airspeed by changing the set power, and it changes automatically depending on the configuration that you have set up or the different elements you're flying through, airspeed, temperature, etc. It'll automatically adjust for that. Auto throttle can do a lot actually, and it's operable through all phases of flight essentially, through takeoff, climb, cruise, descent, approach, go around, landing. It can operate through all of those. Essentially how it works, the auto throttle is coupled with the flight control computer, the FCC, and information is inputted to there through the FMC, along with a few other places, but primarily through the FMC, which starts the process to control the functions it needs to. As you can see right here, I'm going to try and not get in the shadow, so you guys can see. There it is. Alright, so obviously the input is for the FMC right here. Inputs can be sent to the flight control computer, also through the DEU, which in turn can send the information to and from the FMC, also to the EEC, which is the electronic engine controller. It's part of the FADEC system, and this essentially allows the aircraft to change the engine inputs in order to maintain the desired result that it wants. That's enough of my shadow show. Okay, and then essentially there are two working modes to the auto throttle. There are subparts to one of them, but the two main ones are thrust and speed. The first one that we're going to be talking about is thrust. In this mode, the pilot can set the system to maintain a fixed power setting in accordance with the different phases of flight. Say, for example, you're about to take off a runway. You already inputted all of your data. And in order to initiate the setup, you go ahead, press the two go switches on the yoke, which are the takeoff go around switches. Excuse me. After you press those switches, the system moves the throttle forward to the computed N1 value, which is what the engine is going to be set at. It will set to the computed N1 value, and it will move forward to there. Once it gets in that position, it locks in, and the symbol throttle hold will show up on the PFD. This indicates that the throttle is held there, and it won't move until it reaches the next phase of flight, which in this case would be climb. Alright. The other mode, in speed mode, the auto throttle is set to a desired speed to hold at. If you're up at cruise, you wanted to maintain, I don't know, say 150 knots for whatever reason, then you could set up to 150 knots, and the auto throttle would change your configuration in order to allow you to maintain that speed depending on how your aircraft is set up. There are actually different variations of the speed mode. FMC speed. In FMC speed, the speed you want is selected via the FMC, the FCP, I'm sorry. You can input it right here, and it's displayed right here through the indicated airspeed Mach number. You can set in what you want there, and the speed is displayed on here as well. This is mainly used during cruise, during areas of horizontal navigation. The other one is FMC speed. That one is used mainly through vertical navigation. When you're using FMC speed, it will not appear on this section here like it will for NCP. Syllables. There you go. It won't appear up here, but instead, I'm going to loop around here. It will appear as airspeed cursors here. Since this is mainly used during vertical navigation, it will show whether you need to increase your speed, decrease your speed, and it'll hold you there while you're in that phase, either climb, descent, etc. Okay. Obviously, there are plenty of benefits to the auto throttle system, but if you want to talk about the most notable ones, obviously safety can be a really big benefit. Safety, economy, aircraft maintenance, depending on how often it's run. There are a lot of benefits to the system. The first one we're going to talk about, obviously, is safety enhancements. The auto throttle as the name implies, automatically adjusts the throttle to what the pilot wants or needs to be at for whatever phase of flight they're doing. In turn, this allows the pilot to focus on other tasks and aspects of flight, especially during the super busy times when they're about to take off, during descent and approach, when there's a lot of things going along, a lot of checklists need to be checked off and done. This is just one less thing the pilot has to worry about. Obviously like that. It also helps speed during approaches, making it more stabilized. And because of this, it results in fewer instances of poor configuration. This also helps maintain your cruising speed so that way you don't bust your speed bubble. Will bust your speed limit if you're operating near any airports for whatever reason you're up high and you want to go super fast. The next one is economy that we've been talking about. While operating at cruise, the pilots obviously at first have a decent amount to do, but afterwards they want to maintain the best fuel burn they can for the flight, and they can do this using the auto throttle. They set the desired airspeed to maintain, and the throttle will adjust to maintain the inputted airspeed. Of course, factors can change during flight if you're going from an area of hot to cold, high-low temperature, dew point, etc. The configuration could change on what would be the best place for your airspeed to be at. It can sense that, and then it will change automatically depending on the factors, performance, altitude, temperature, whatever will get you the best performance. So this allows for optimal fuel efficiency, and also it minimizes unnecessary fuel burn and the power changes. You don't want to have to change power every so often, so that way if it's gradual and the small change, it'll help a lot with that as well. It'll also help with maintenance overall in the long run, because less big changes in fuel means less maintenance needed on engines, longer engine life, etc. And obviously less maintenance and overhaul for those as well. Applicability, generally speaking, the auto throttle is really used in larger aircraft, ATP, transport category aircraft. You see them in essentially all airliners, large airliners. Makes it a lot easier for pilots to operate those things. A lot of business jets actually have them as well. A lot of business jets obviously want the smoothest ride possible for their clients, so they incorporate the auto throttle in order to help with that. There are actually some smaller aircraft with the auto throttle system as well. One of them, for example, to give you a size on how small they can go down to, is the Eclipse 550. That is the aircraft pictured on the right over there. Another one actually is a smaller jet aircraft. The other one is a little bit of a weird one. It's another one, the PC-12. The PC-12 can be outfitted with an auto throttle system as well. It's a bit of an exception. PC-12 doesn't have a FADEC system, or that's essentially the EEC, but it works in a little bit of a different way for that aircraft. But typically you won't see them in aircraft smaller than that. Turboprop really is as low as they go. You won't see them in many more systems, especially in single engine operations, unless that pilot is really good with maintenance. It's a little bit too large to fit in. The cost overall, I couldn't find an exact concrete cost for the auto throttle system, but I was able to look at some information from here and there. It can vary depending on the aircraft that you're installing it in and everything like that. For example, the smaller aircraft at PC-12 and the Eclipse 550, typically it's gonna vary a little bit, but the average cost is about $60,000. For larger aircraft, transport category, business jets, this is where there's a bit more interpolation involved, but I was able to find the price around to be $200,000. It's not exactly a cheap system, but from what it gives you, it's definitely worth the price. And also, as for the FAA mandates go, I couldn't exactly find specific FAA mandates for auto throttle systems. However, the auto throttle is coupled a lot with the autopilot. So there are a couple autopilot things, essentially just criteria for operational approval of autopilot and flight guidance system. Those are AC 120-67, AC 25.13291C. Those are just going over approval of flight guidance systems, auto flight guidance systems, such like that. It can be related. It's coupled a lot with the auto throttle systems, so it does that too. First of all, great movie. Second of all, personal thoughts on the auto throttle system. It's great. It's fantastic. The amount of safety it gives you, economic boosts and everything as well. It's fantastic. It's a staple in large commercial aircraft. It helps save money overall, and the overall impact is irreplaceable. It should be made much more available in smaller aircraft for smaller commercial pilots. Like I said, it will get down to some degree of smaller aircraft, but with the size of it and the cost, a lot of them can't afford it. But it would be fantastic if a lot more aircraft could have the auto throttle system for it as well. Speed, I like that movie a little bit. So, we're a side page and peace out. Let's drop in the mic.